Okay, so now we are going to do the second half of this page. I'm still in your guided notes on page 13, and we're looking at double replacements reactions whenever we don't get a precipitant, which really in the end is going to become a no reaction. There's none of the clues of a chemical reaction will happen. So I'm going to go ahead and write it out right now so that we see what the product should have been if a reaction occurs. That's the only way that we're going to know if it does, but I will write it a second time so that you can see really how should we describe what's going on. Clues of a chemical reaction: change in energy, change in color, meaning like a new color is produced, change in odor, a precipitant forming, or effervescence. If those clues don't happen, a chemical reaction did not occur. So we cannot say that there's new products, all right? So that's the end of what we're getting at, but we won't know that until we actually look at the reference sheet and figure out what that reference sheet is telling us. So again, if you double check both of these compounds, you're going to see using the reference sheet that they are aqueous, and we need them to be aqueous. Okay, and in this particular case, for precipitant forming reactions, we do need them to be aqueous because that's kind of the block of which the reaction occurs. Okay, so I'm just going to rewrite these. Hopefully write small enough so I can get everything to fit. Okay, now again, I'm in the midst of figuring out what the products are. I don't really know if a reaction happens yet or not, but I won't know until I start to practice, writing what those compounds are. So lithium is now going to react or combine potentially with chlorine if something does happen. And then the sodium is going to combine with the phosphate. We would end up with that type of thing. Let's see, if we were to go back and balance this, looks like we would put a 3 here. Again, I'm just assuming the reaction happens. We're going to see how, in reality, it just doesn't. And how am I going to know that? If both of these are aqueous, then there is no change. There is no reaction. The only way a reaction happens is if one of these is precipitant forming. And that's something we have to get at with double replacement reactions. So I'm going to look at my chloride, my lithium chloride, this first one here. Okay, so chloride ions. All right. Well, the only thing that would be a precipitant is if it's a chloride that's combined with any of these, and it's not. So instead, we have chloride that is combined with lithium, which is going to be soluble. So that's aqueous. Okay, so for this first one, I can write in aqueous. So then maybe it's the phosphate that is going to produce my precipitant. So let's look at this. Phosphate, all right? And remember, it was sodium phosphate. Well, phosphate combined with sodium, oh, never mind. That's soluble, which means it's aqueous. So this is also aqueous. So nothing, there's no visible reaction because there is no reaction. Nothing forms. So what we really would do in this case, once we realize this, if I was writing this on a quiz or something like that and being asked to determine what the products are, the truth is there is no product. I would write no reaction. Nothing happens. So then for this next part, the insoluble salt was nothing. There is no reaction. But I still can draw what is going on. It's just the before and after, no matter what, is exactly the same. So if I have a beaker, and in this beaker, I add a large amount of aqueous sodium chloride. This is just saline solution, right? And then I combine that with aqueous lithium phosphate. What am I going to see in here? Well, I'm going to see sodium ions. I'm going to see chlorine ions floating. I really won't see these, right? They're super small. But if we could look at the very microscopic level, we would see these. We would see lithium ions floating around. If you wanted to draw in 3 to just mimic what that equation looks like, you absolutely could. Okay, so I could put all those in there. And then I'm going to see phosphate. And the important thing is nothing combines together like we had over here, and we had precipitant fall out. Nothing falls out. It stays in solution. All right, so net ionic equation, there is none in A. Nothing can happen here. All right, so some pretty significant differences between precipitant forming ones, and then those that are not. So we're going to apply this information then and look at how to do that with the lab and how to interpret our lab. And that's our next step.